Bryan, you're the CTO for energy industry for IBM. So how do you see your peers at your customers tackling generative AI opportunities?
Generative AI is a really unique and interesting technology. It's something that's been fairly obscure in the research lab, including IBM's lab, for many, many years. It hit the market in a big way less than a year ago, and it's now the fastest growing technology. It's something that with every conversation, with every C-suite down to every intern, we end up talking about generative. It's top of mind with those executives. Now, this has put them in a bit of an awkward place where most of our utilities executives recognize the challenges and the dangers of leveraging this technology, but every single employee is actually using it in not necessarily the most effective way. And so what our clients have been trying to do is figure out ways to support the needs of all of their employees, but start to put the guardrails in place to provide some protection. So if you think about what they've done, many utilities start with a blanket policy that says no use of this technology. And the challenge they have is that employees have been using it anyway, including uploading private and sensitive information up to a cloud somewhere where they don't have protection over that data. What has followed was putting in almost a private implementation or a segregated instance where their employees can start to use this technology. The problem is that that only addresses one piece, which is the privacy issue. It doesn't address a lot of the other major issues that we have with generative technology. It doesn't address the need to have explainability, the ability to understand where is this insight coming from? Can I audit it? Can I prove, why and where I'm using this information from? It doesn't solve the problems around bias. Is there bias in the training data that's going to make me favor a certain subset of my utility infrastructure or my utility customer base? It doesn't monitor for things like drift. It doesn't handle the legal challenges of using copyright information. So we've started to address some of the problems, but it's not getting to the real heart of how we're going to use this technology going forward. Now, what I've been seeing is some of the most, responsible and effective approach is to say, I want to start using this technology, but I want to use my initial use cases to start thinking about how I build in governance, how I build in that explainability, how I build in detection for bias and drift, how I start thinking about what happens if I need to change models from one model to another. And, putting that framework in place is a very effective way to start to get value and learn, but start to put the underpinnings in place to have a really responsible architecture for driving forward with generative technology, which is really nascent at this time. It's going to grow exponentially, and the value that it's going to provide is going to be remarkable moving forward.
Now, for the value that generative AI is going to bring, for that to happen, is there a shift in the skill set that employees and companies need?
There is. Something to keep in mind is people think that generative AI is almost magic, where you can apply it to any situation and you're going to get results out. And that's not really the case. The use of traditional artificial intelligence is still going to be a large portion of the artificial intelligence work that our utilities are going to be using. And when we think about the skill sets that you need, in generative or traditional AI, we still need to have a focus on quality data. So putting in appropriate data governance programs to ensure that we know where the data comes from, we know the quality of that data, we've got lineage of that data, all of that still remains in place. Now, when we start thinking about the generative side, there are some new skills that are going to be required. We need people who can understand the different models that are available, either within the marketplace or in the open source community, or ones that they might build themselves, and understand which are the best models to apply to a given problem set. We need people who understand how to do things like prompt engineering, or to do fine tuning of models in order to get more value out of these generative models. So these are some of the core technical skills that we'll see. There's also a new set of skills, and that's more in the, I'll call it the operational side. So how do we deploy models in an effective way and monitor those models with the governance in place in order to ensure that we can get value out of these and meet the needs of the business and the auditors and the regulators, which is fundamental to the role of utility. And then there's a third set of skills that we need to develop as a muscle, and that's really around, in some cases, we'll call it an ethics board. But How do we start looking at our executives, our chief legal counsel, start to understand the implications of leveraging this technology, start to understand the ethical issues of dealing with our workers and our unions, start to understand issues like bias that are going to impact our customer base, and use that in order to set policy and direction as to how we move forward with generative.
Generative AI is built on foundation models. Now, what are these, and where do you see these things developing or going in the future?
So what's fascinating about generative, and what makes it so powerful, is that we do use these things called foundational models. If I think about traditional AI, what I'm doing is I'm tackling a single problem. I'm going to figure out what data I think is going to be useful for it, and I'm building very specific models in order to solve that problem. A foundation model looks at a much broader data set. And what we're doing is we're creating a model that can be used to solve multiple problems. I'm not building it to tackle one issue. I'm tackling a whole host of issues, many of which I don't even know exist yet. Right? So that's the power of a foundation model. Now, when we do that, we have to understand the data that we're using to train that model. It's called a data pile. But is there copyright information in there? Is there explicit language in there that we need to filter out? Is there false data that has been created? Is there bias within those data sets? So it's very important to have that quality data in order to have confidence in the results that are coming out from these foundation models. Now, the other thing to keep in mind is that that first approach we talked about, where essentially what we're doing is we're picking a large language model and we're making it available to our employees. That's not going to solve all of our problems. Going forward, what we expect is to have a set of smaller models that are focused on very specific areas. So we might have a large language model that we're using within customer or within regulatory. There might be one of those models, as an example, that is no longer we're no longer allowed to use it because it's stale data, or legally they've used copyright information and they're not allowed to bring that to market. So there's all sorts of situations where we might want to be able to switch from one model to another. What we're also seeing is that generative AI can go far beyond what we're doing with large language models. You see some things out in the marketplace for doing videos or for doing photos. Where we've done work recently, for example, is in the area of geospatial data. So we've worked with a partnership with NASA and our weather data, and we've created a generative AI model specifically around climate risk. So now as a utility, I can start to use this model to understand things like flooding risks that are going to impact my assets within the field. We've got a significant amount of work going on in our research area with some of the leading papers being published through our research team, looking at applying this type of technology to time series data. This is all the SCADA data, the smart meter data, all the sensor data, to make better sense of it and help our utilities do everything from operations through predictive maintenance. So as we start thinking about how we build our architecture for handling generative, yes, there's some things that we can do with large language models, but we want to have the ability to support multiple models as they evolve over the coming 1 to 5 years, and have all of that governance in place that we talked about to make sure that we have explainability, that we can detect for drift, we can detect for bias, right? And that's really the approach that we should be looking at, is how to put those foundations in place so we can really get the value out of generative in a safe way.